Welcome to Kanerika's podcast, The Digital Shift, where we bypass the complexity and zero in on the strategies that define enterprise technology today.
And today, we're tackling a big one.
We are. If you are responsible for digital transformation, you know that moving enterprise data, mission-critical data, is the foundation of any successful modernization effort.
Yeah, it absolutely is.
But here's the paradox. While it's the most fundamental task, it is also the most likely to cause massive corporate headaches.
It's the silent killer of transformation budgets, and the statistics are, well, they're shocking.
Go on.
The content we've analyzed highlights a figure from Gartner that should make anyone in IT governance sit up straight. A staggering 83% of data migration projects either fail outright or just completely exceed their budgets and timelines.
83%. That's unbelievable.
It is. And when you think about the scope, we're often talking petabytes of information.
Yeah.
That failure rate isn't just a technical glitch. It represents billions in wasted investment and, crippling delays to innovation.
That 83% number is staggering. And I have to ask, is that failure purely a technical issue? Or are we talking about a combination of technical failure coupled with, say, business users simply rejecting the new system because critical business logic got broken in the move?
That's a crucial distinction. It's rarely just about the pipes. A huge portion of that failure rate comes from a lack of strategic planning up front, kind of treating a complex migration as a simple copy-paste.
So our mission today is to get ahead of that.
Exactly. Our mission is to dissect the complexities by exploring the 7 major, distinct types of data migration that this content identifies. By understanding these differences, you can select the correct strategy, reduce that monumental risk, and, make sure your data foundation is perfectly primed for the future of AI and advanced analytics.
Okay, so let's frame this correctly. Data migration isn't just an IT task anymore.
Not at all. It's a strategic imperative. We define it as the structured, controlled process of transferring data between any number of environments, storage systems, databases, applications, cloud platforms. You can't just move the bits. You have to preserve absolute accuracy, security, and most importantly, business continuity.
Business continuity, that's the key.
If the business stops, the migration has failed. It doesn't matter how clean the data is on the other side.
So why is this gaining such critical weight right now? Why are companies suddenly prioritizing this after years of just patching systems together?
There are 4 key strategic drivers forcing the issue today, and they all point toward a massive architectural overhaul. First, you have the undeniable tidal wave of cloud adoption.
Right, moving workloads to AWS, Azure, Google Cloud.
Exactly. And it's not just about cost savings anymore. It's about achieving true elastic scalability and getting away from aging, expensive on-prem hardware.
Okay, that's one. What's the second driver?
Second is the aggressive push for system modernization. Companies are finally retiring those rigid proprietary legacy platforms and rebuilding on modern cloud-native architectures. Often they're embracing data lakehouses designed for flexibility.
And third?
The third, and maybe the least forgiving driver, is regulatory compliance. GDPR, HIPAA, SOX. These are constantly evolving.
And they demand more than just secure data.
They demand an auditable record of the data's entire journey. You cannot just lift and shift without managing compliance gaps, or you're risking massive fines.
And finally, the ultimate goal, which you touched on earlier.
AI and analytics initiatives.
Right.
Predictive and generative models are not magic. They are data consumers. They are completely useless without clean, structured, and trusted data that includes verifiable lineage. If your current architecture can't deliver that, your multi-million-dollar AI strategy is dead on arrival.
And if we connect this back to the bigger picture, choosing the wrong migration type can have a profound impact.
Oh, it's profound. Imagine using a simple Big Bang approach, a complete instantaneous cutover for a highly complex application when a phased strategy was really what was needed.
That sounds like a disaster waiting to happen.
It leads to weeks of unplanned downtime, cost overruns that just spiral out of control, and worst of all, it permanently limits your future analytics capabilities because the data structure wasn't optimized. The strategy has to be right from the start.
This is where we need to get specific then. The content identifies 7 distinct categories. Let's walk through them, maybe from the most foundational to the most application-centered.
Okay, that was good.
Let's start at the foundation. Storage migration. What are we really talking about here?
This is about moving the raw data files, blocks, objects between physical storage systems. A classic example is moving from an on-prem NAS or network-attached storage to a scalable cloud solution like Azure Blob or Amazon S3.
And the goal here is pretty straightforward, I assume.
It's usually focused on the bottom line: lower storage costs, better durability, near infinite scalability. But the key challenge is the sheer volume.
Right.
When you're dealing with petabytes of data, managing that bulk transfer and minimizing the downtime risk for your business-critical applications, well, it's immense. You need highly efficient parallel transfer tools to manage that scale without freezing the business.
Okay, so if storage is the foundation, the complexity instantly skyrockets when we move up a layer to database migration. What are the unique headaches here?
This is fascinating because the motivation is often strategic and financial.
Yeah.
Shifting from Oracle to an open source option like PostgreSQL to slash licensing costs, or moving SQL Server to Azure SQL to go cloud native.
But the technical hurdle is huge.
It is. It's schema incompatibility. Different databases speak different dialects of SQL, and rewriting complex stored procedures, triggers, views, which are often totally undocumented, can take 3 times longer than the actual data transfer.
Wow.
It's like trying to change the foundation of a building while everyone is still living inside.
Okay, next up, type 3, cloud data migration. This seems like a big umbrella term.
It is. It covers moving data into the cloud from on-premise or even cloud-to-cloud transfers. The goal is achieving that elastic scale, better disaster recovery, and faster innovation through managed services.
But this one raises all sorts of security questions.
It raises the critical question of perimeter security. How do you manage the massive security exposure during that transfer, especially with sensitive data? End-to-end encryption is non-negotiable, but organizations often overlook, preventing compliance gaps.
Just because it's in the cloud doesn't mean it's compliant.
Exactly. The migration process itself has to be fully auditable.
Moving on to type 4, application data migration. This is where the business users really feel it, right?
This is absolutely the most visible type of migration failure to a business user. A classic example is migrating data from an old ERP system like SAP ECC to S/4HANA, or moving a legacy CRM to Microsoft Dynamics 365.
And the challenge isn't just moving files.
No, the challenge is preserving the complex, embedded business logic dependency. Imagine migrating a payroll system. If the logic for calculating vacation time or bonuses breaks, even slightly, user trust just evaporates instantly.
That makes perfect sense. The risk of broken logic is key. Now, type 5, which is arguably the most strategic in the age of AI, data warehouse migration.
Right. This means modernizing your analytical data from legacy systems, say Teradata or an Oracle data warehouse, to advanced cloud solutions like Snowflake or Microsoft Fabric.
And this is the direct path to enabling AI and ML.
It is the straightest line to AI and ML enablement. If you want advanced analytics, you need a modern platform. The technical challenge, though, is the enormous weight of accumulated technical debt.
What does that look like in practice?
We see persistent issues with query rewrites due to different SQL dialects, and the massive effort to ensure all the existing BI reports, the ones executives rely on daily, remain compatible and accurate. A migration that breaks the CEO's dashboard, even for a day, is a failed migration.
Next up, number 6, ETL, or pipeline migration. This sounds like we're getting into the engine room.
We are. This is about modernizing the transformation logic and orchestration workflows that clean and shape your data. Think moving from tools like Informatica or SSIS to modern cloud-native solutions like Talend or Microsoft Fabric.
The goal being improved reliability and scalability.
Precisely. And easier maintenance by replacing old custom scripts with standardized patterns. But this is where the dark matter of data lives.
Dark matter?
Yeah, those complex ad hoc business rules buried deep in old code. There's a huge risk of logic loss or overlooking hidden dependencies. You might find a seemingly simple script contained a critical rule for filtering fraudulent transactions, and if that gets lost, the business consequences are immediate and severe.
And that brings us to the final one, type 7, legacy system modernization.
This is about retiring those truly outdated platforms, ancient mainframes, proprietary flat files that lack security, lack vendor support, often because the people who wrote the code retired a decade ago.
So the risk here is just off the charts.
The inherent high business risk defines this category. These systems almost always support mission-critical, revenue-generating processes. The challenge is often logistical. Poor or missing documentation. Embedded business rules. It's a high-stakes archaeology project where if you fail, the entire business process can just stop.
So we've covered all 7, and it's clear the selection strategy is the critical first step. Let's circle back to that 83% failure rate. If enterprises know about these different types, why does that simplistic lift-and-shift approach persist?
The primary error, as the content highlights, is the assumption that all data is equal. A simple lift and shift where you move data without changing its structure works perfectly for basic storage migration.
For the simple stuff.
But applying that same simple technique to complex analytical or application datasets is a costly fundamental mistake. The new cloud system is designed to expect optimized data structures. If you just dump old proprietary formats into it, you instantly get performance issues, you break reports, and you create glaring compliance holes.
So the practical recommendation is that successful programs are almost never a single action.
They're almost always phased and hybrid strategies. A mix of storage updates, pipeline modernization, and gradual application adoption. You have to treat this like a multi-stage campaign, not a quick move across town.
Which means the decision framework has to be really robust.
Absolutely. You have to guide your selection by 3 core pillars. Your overall business goals. Is it cost reduction or innovation? Second, the raw data volume and complexity. And critically, your downtime tolerance. For real-time systems, a zero downtime approach is the only option.
Acknowledging that complexity and these hybrid strategies require sophisticated solutions. I mean, this is clearly beyond manual efforts. We've moved past spreadsheets and scripting, haven't we?
We have. We at Kanerika recognize that manual migration is the primary cause of that 83% failure rate. It's just too prone to human error and logic loss. That's why we developed the FLIP platform.
Okay, tell me about FLOP.
FLIP is an AI-powered, low-code DataOps solution. Its core function is to automate the most treacherous parts of the migration. Intelligent discovery, schema mapping, transformation logic, automated validation, and full lineage extraction.
And the impact of that automation has to be pretty dramatic.
It's measurable and dramatic. FLIP's intelligent migration accelerators can automate up to 70–80% of that repetitive migration work that just plagues IT teams.
So you're cutting timelines and minimizing human error.
Drastically. And you're ensuring the preservation of that critical business logic we just talked about, especially during those high-risk transitions.
Can you give me a specific example?
Sure. Because of this need for precise automation, we at Kanerika manage highly complex cross-platform transitions every day. For instance, our tooling can convert proprietary Informatica jobs into fully compliant Databricks notebooks or modern Microsoft Fabric pipelines.
And on the business intelligence side?
On the business front, we automate the painful migration of legacy systems like Crystal Reports or Cognos reports to Microsoft Power BI, automatically maintaining all the underlying calculations and even the visual fidelity.
And the results really prove out the value.
They do. We partnered with a leading laboratory organization that faced a massive analytics bottleneck. By using FLIP's accelerated tooling, they achieved an 80% reduction in report preparation effort by migrating their old Crystal reports to Power BI.
That's not just an efficiency gain.
No, that directly accelerated analytics adoption and decision-making among their executive and scientific teams. It transforms a maintenance problem into an innovation driver.
So to wrap up that point,
in strategic conclusion, what we at Kanerika offer isn't just a tool. It's the combination of automation, governance expertise, and comprehensive security. This approach minimizes the critical risks, data loss, downtime, hidden dependencies, and consistently delivers scalable, compliant, and AI-ready data platforms.
that was quite the deep dive. And hopefully you now have a much clearer map of the strategic landscape. We covered why migration is a strategic imperative, the risks of choosing the wrong type, and we explored all 7 categories: storage, database, cloud, application, data warehouse, ETL pipeline, and legacy system modernization. The takeaway is clear. The strategic decision of which type to use is paramount.
And that leaves us with one final provocative thought for you to consider as you plan your own digital shift.
Let's hear it.
Data migration should no longer be viewed as a cost center or, a necessary evil to be endured. Instead, you should view it as the foundational step that transforms your organization's data from a liability into a genuine growth enabler. It's what allows for continuous innovation and provides the real-time insights that were previously impossible on those rigid legacy systems.
A truly strategic perspective to end on. The shift is digital, but the foundation is data quality and architectural strategy. Thank you for joining us for this deep dive into data migration on Kanerika's podcast, The Digital Shift. We'll catch you next time.